Hello everyone and welcome back. My name is Mr. Cobalt and I'm going to go over a couple of problems involving gas evolution reactions. So when you're given a problem, you may not be told that it is a gas evolution reaction problem, or you might be told, but the harder problem is they won't tell you it's a gas evolution reaction problem, but they'll want you to be able to identify it as such. So they might give you a problem like this where they say write the molecular equation for a reaction that occurs when you mix aqueous nitric acid and aqueous sodium carbonate. So you're going to treat this like a normal problem. So you need to know what nitric acid is and the sodium carbonate. You need to know the formulas. So we're going to write down the formulas. So nitric acid, you should know, is HNO3, and that's aqueous. And then you're going to react that with aqueous sodium carbonate. So we're going to sodium carbonate, that's going to be Na2CO3, and that's aqueous. And then we're going to predict our products. So we're going to predict the products like we normally do. So we're going to take the inside species. We have sodium and nitrate. We're going to put those together, and we need to make sure we balance the charge. So this is going to be a +1, -1. So we need one each. NaNO3, and then that's going to be one substance. And then the other substance, we take the ions here. So we take the carbonate and we take the hydrogen and we balance those. So hydrogen is going to be a plus, carbonate is going to be a -2, so we need two hydrogens and the carbonate. Now, the next thing we need to do is we need to balance the equation. So also we need to make sure we take a look at these and see what state they're in. So if this is sodium nitrate, I would look that up on my solubility chart, and that would be aqueous. So that's going to be aqueous. And then this is an acid. This is my carbonic acid, and that's going to be aqueous as well. And so now I want to make sure we balance the equation. So here I have sodiums. I have two sodiums. I only have one sodium over here, so we need to put a 2 there. And I have one carbonate and one carbonate, so that's good. And then I have NO3. I only have one here, but I have two here now, so I need to put a 2 there. And I have two hydrogens now, and so I have two hydrogens there. So now it's balanced. So this might be the actual equation you write down, but are we done? So here we have a balanced molecular equation. But is there more to this? This is where you need to recognize that you might have an intermediate that is going to break down into a gas. And so here you have to recognize that carbonic acid is an intermediate. And what that's going to break down into is water. So you subtract out the water, and then what's left is CO2. And there's your gas. So the molecular equation would end up being 2 moles of HNO3 aqueous plus 1 of these, and sodium carbonate aqueous goes to 2 moles of sodium nitrate and 1 mole of water and 1 mole of carbon dioxide gas. So that would be your molecular equation. So you got to watch out for the intermediates for gas formation. What about problem number 2? It's same type of question. Write a molecular equation for the reaction that occurs when you mix aqueous hydrobromic acid with aqueous potassium sulfite. Okay, so let's write that down. So we have hydrobromic acid aqueous. So we need to know what the formula is. That's going to be HBr, and that's aqueous. And we're going to add to that, we're going to react with that aqueous potassium sulfite. So we need to write that down as well. So we have potassium sulfite, and sulfite has a 3 and it's got a -2, so I need 2 potassiums to balance the charge, and that's aqueous. And then I predict the products like usual. So I'm going to take the inside ones, potassium ion and bromide ion go together, and that's going to be KBr, and that's going to be aqueous because I looked on my periodic, I looked on the solubility chart, and you'll know that potassium is going to be aqueous when it's in a salt. So then here, we're going to put the sulfite and the hydrogen together, and that's going to make my sulfurous acid. That's going to be H2SO3, and that's going to be aqueous as well because it's an acid. And so let's make sure we balance our equation. So I have 2 potassium, so I need 2 potassium there. I have 2 Br, so I'm going to need 2 Br there, so put a 2 there. So now I have 2 Br, 2 Br, 2 potassium, 2 potassium. I have, let's say, SO3, my sulfide. I have 1 there, 1 there, and I have 2 hydrogens and 2 hydrogens. So now it's balanced. So again, we can't stop there. We need to verify, we need to check to make sure, one, that we don't get a precipitate, right? So this could be a precipitate reaction. So we check our solubility rules, our solubility chart. So there's no precipitate here. So again, if you stopped at the precipitate and say, well, there's no water being formed, it's not an acid-base neutralization. So you might think that if I have aqueous on this side and I have aqueous on this side, then there's no product is formed, and so therefore it's a no reaction. But again, you have to watch out for your intermediates for gas evolution. So right away you should see, okay, well, I have sulfurous acid. Sulfurous acid can break down into water, liquid water, and SO2 gas. So that would be the products that I would form. So this is just an intermediate. So the final product is going to be water and sulfur dioxide gas and the aqueous potassium bromide. So that's what you would write down. So if you just stop here, then you would be only halfway there. So be careful of these reactions and be on the lookout for intermediates that could break down into water and a gas, or that, or if you get a gas right away, like H2S. So be on the lookout for that. I hope this is helpful, and thank you for joining me. If you like this video, like it, share it with your friends, make a comment in the comment section. You want to subscribe to the channel and ring the bell notification so you can get notified by videos that I'm going to come out later. So thanks for joining me, and I'll see you next time.